Okay guys, and welcome back for another video on the MBED controllers. And in this video, our small embedded system is going to monitor temperature for you. So we've got a small temperature sensor here, and basically it's just going to display the temperature to the LCD screen. Okay, now what I'm going to do is I'm actually going to jump into the video first, just so we can have a look at the solution working and talk through a bit of the setup. The setup is fairly straightforward. Now we've got a couple of components here. Basically what we've got is we've got an analog input, which is our temperature sensor, LM35. We've also got the potentiometer there. Now, to be honest, they're both analog inputs. Okay, one is actually only going into our MBED, the other we're using as a brightness control or contrast control. But you'll see with the analog stuff, they're all wired the same way. They've got 3 wires, one goes to the power supply, one goes to ground, and the middle wire goes to where you want the analog input. Okay? So this is just a different type of potentiometer. Just to change up what you could see, you need to use the flathead screwdriver there to actually turn the dial, rather than when you have the pole to twist it. Okay. The other thing in the video I'm just drawing your attention to is make sure you have the flat side facing you for this configuration. Okay, so make sure you know which leg is the positive and which leg is the ground supply. Doesn't matter what potentiometer, you can do either side, you can swap those two around, doesn't really matter. But with the temperature sensor, the LM35, it does matter. So make sure that's connected the right way around. Now what we've just got here, we've got a power supply set up, and then we've got our display. Okay, now sorry it's upside down, but basically when we reset the system, we've got a little bit of a welcome message, and then it continuously displays the value of temperature. There's just that potentiometer being worked there just with the screwdriver, adjusting the contrast of the LCD display. So note we've got temperature in Celsius and temperature in Fahrenheit. Okay. And sorry that it's upside down. But that's just essentially what we're doing. You could, hold your hand over the temperature sensor for a wee while, and you'll see maybe the temperature increasing or decreasing, and it'll give you a rough gauge of what the temperature is at. Okay. So that's all we're looking for. We're just looking to connect up the temperature sensor and feed the data into the MBED, and then for the MBED to display that data into the LCD. And then we have the potentiometer there just to control the brightness. You could maybe use some resistor setups to control that as well. And we've covered that in other videos. Okay. So the main thing really that we want to discuss about is the code and setting up the sensor, the analog sensor, and how that works. So I've explained pretty much the wiring diagram here, and look, we've done a couple of videos and tasks on the LCD. We've done some discussion on the potentiometer and things like that before, and the power supply. So the setup shouldn't be too difficult. Just again, make sure your power supply rails are set up appropriately to where you need 5 volts and 3.3, and make sure your temperature sensor is orientated in the right direction. As always, make sure you're comfortable with some of these diagrams here. This is the proper schematic. There's your temperature sensor, the 3 pins labelled. There's your potentiometer. There's your separate voltage supply. We know that's where we're getting our 3.3 volts from the V out. So make sure you can follow this. Now we jump into the code, and we'll have a little bit of a discussion on the code here. Like I said, we've done some videos on the LCD, so I'm not going to discuss that too much. I just want to bring our focus to the new stuff that we're looking at. So we have an analog input coming in, and that's just our LM35, our temperature sensor. So it's coming in pin 15, that is one of the 5 analog input pins we have available. We got to do some calculations, and we got to store this information in some variables. So what's what I've done here. And we're using floats because we've got a decimal point accuracy in it. So we've got a variable that will store the temperature in Celsius, so our temperature in Fahrenheit. We've got the raw value of the sensor, and then the V out, what is actually the outputted voltage at that moment in time for the sensor. Now we come into our main loop. We've just got a welcome message. Okay, so we've seen something like that before, so we'll not worry about that too much. And then we have an infinite while loop here that basically, once we've done the welcome message, we don't need to display that anymore. So we'll just basically loop through this for infinity. And essentially we're checking the value of the sensor every 2 seconds. Because we go through this calculation, we display the results, or the current results of our temperature, and then we wait 2 seconds, and then we go ahead and check again for a new value in the temperature sensor. So we have a 3.3 volt connection, power supply to our temperature sensor. So we've got to work out the temperature based on that supply voltage. And remember, this is changing as the temperature changes. Now, when you look at the data sheet, you will be given a formula that will tell you how to calculate your temperature in degrees Celsius. So this is given to us from the data sheet. So you have the data sheet available for you, and we'll discuss it in class, and you'll read through it and learn a bit more about it. It tells you how it wires up, tells you the accuracy, tells you what voltage supply you can give it, and it talks about resolution and different things within it. But essentially, it gives us this formula, and that's all we need to know. Okay? So once we get this voltage, we can convert it to a temperature. Okay? Now, we've learnt a bit about analog reading in an analog voltage before from our potentiometer. It's the exact same thing we're doing. We're doing our normalizing and we're doing our scaling. So we know our normalized value will give us a value between 0 and 1. And that essentially then needs to be scaled against the maxed value that we're using, or the max power supply that we're using with the component. So the read function does the normalizing for us, makes it nice and easy, and gives us this raw value. Okay, that'll be a value between 0 and 1. That's based on the resolution of the analog to digital converter. The more bits we have available for that, the more accurate this number will be. But essentially we get that number, we get that raw value, and then we got to scale it against 3.3 volts. Now we actually use 3,300 millivolts because that's what the formula states in the data sheet, that this must be in millivolts. So that's why that value is there. Then once we get that, we just put it into that formula, and we have the current temperature in Celsius. If we want to calculate the temperature in Fahrenheit, we've got our standard formula that you can find online to convert temperature from Celsius to Fahrenheit, and that's roughly it there. Then once we've got those values, we just display it. And we're displaying it on 2 lines, so that's why we move to the next line down here. And then we've seen before how we display a variable into our LCD. We've got to use this keyword here, percentage and F, because it's a float. It's a float variable, that's what we declared it as. Okay, and then we're given it how much decimal points we want to show. We're going to show 2 decimal points to the right, 1 decimal point to the left, but if it actually increases, it will automatically add on a new space to the left there. And then we just display the same thing, but for temperature F Fahrenheit. It'll wait 2 seconds, and then it will loop back around. It will clear our LCD screen, and then it will read the temperature again. And that's essentially what's happening with our analog input, automatically updating, a little bit different to our potentiometer, because potentiometer we're manually changing that analog value. Here this is automatically updating due to the current temperature in the room. But you can see a lot of similarities, normalizing the scaling and then taking a formula from the data sheet. So that's the task. That's everything that's in it. As I said, it links into a couple of other videos that we've covered, so be sure to watch them. And be sure to understand our connection board here, our pictorial representation, but also make sure you've got a good understanding of the proper schematic too. have a look at the data sheet. It's 38 pages long, but see, can you pick out a couple of the key points that's relevant to us? And maybe can you spot that formula that's in here? I'm not quite sure of the page number. I think it's down here. There we are there. It's the transfer function there. See the way it's in millivolts, and that's how we work it out. Okay, thank you. Hope you enjoyed the video.